Welcome to Flipped
Geometry.
So we've talked about our triangle congruence theorems at length. I'm just going to write them down if you're more of a visual learner. We've got the SsA, angle side angle. We've got the AS, angle angle side. We've got the SAS, that's the side angle side, and then we've got the SsS, triangle congruence theorems, plural. Sorry for the sloppy handwriting. So notice that each of these only have 3 pieces of information. So the case that we're going to talk about next is called the SsA triangle congruence theorem. It is called the ambiguous case. The ambiguous case. You are all very, very smart, so I'm sure you know what ambiguous means. Like frobs are ambiguous. Salamanders are ambiguous. Newts are ambiguous. No, that's amphibious. A person who's both right and left-handed is ambiguous. Nope, that person is ambidextrous. Ambiguous means unclear, or it could go either way. So when we talk about an ambiguous case of a triangle, what do we really mean? Well, let's draw a picture to explain an ambiguous case. So remember, in general, I'm talking about a triangle, and I have 3 pieces of information. I've got a side. I've got, and I'm going to just denote that that has side length with 1 tick. You know, I'm drawing this in the most generic way that I possibly can. So I'm not really going to assign angle or side or measurement or length to any of these pieces. And then I've got some angle, and this is defined. This is determined. Then I've got another side, and I'm going to give this a length of 2 tick marks. Again, I'm trying to draw this as generically as I can. So I've got 2 tick marks here. This bottom side, you should know, is undefined. But if I walk this through, I have side A, or side angle. So SsA. So this is not enough to determine that this triangle is congruent to another. And let me show you what I mean. So let's say I have another triangle right next to it, and I've got an angle, and it's the same angle over here. You're gonna have to trust me because I'm not measuring these things out, but because this is a schematic. Schematic just means this is the plan, this is the design. It doesn't have to be to scale, but it's just a schematic. I've got the same side. This side corresponds with this side. And then over here, I've got my side sub 2, we could call it. We could call it side sub 1, side sub 2. So this side corresponds to that side, this side corresponds to that side, and lo and behold, these are not the same triangle. These are not congruent. Okay, so if I have, well, another way you can picture this is if I were to overlay these triangles, that I could have an angle that's defined, it's locked in place. I could have a side that's defined, that's locked in place. I could have another side that's locked in place. So this is triangle number 1. Everything is the same on triangle number 2, except for this angle instead of, or this side instead of being swung, so this triangle is smaller, it swings over here, so it's bigger. And you'll see that this overlaid triangle makes an isosceles triangle. I hope that this makes some sense, but you should just know this is called the side angle ambiguous case. there is such a thing as the side, like a longer side, smaller side, angle, triangle, congruence theorem. Which is actually really helpful. The ambiguous case is just something you should know about, but it might not actually impact your day-to-day life that much. The larger side, smaller side, angle, triangle congruence theorem says that I still have 3 corresponding parts that are congruent to, on one triangle, that are congruent to the corresponding parts on another triangle. But I have to know the order and the size of these things. So if we look at this same case, and I have a triangle laid out here, so I've got an angle, I've got a side, and then I could have another side. And this bottom side is undefined. So I would ask you, which side looks like it is longest? S1 or S2? Well, S1 looks like it's longest because this angle right here is more obtuse than this angle. This angle is obtuse and this is acute. So we'll learn in pre-calculus later this thing called the law of sines, which means the side length opposite an angle, they correspond. There's a relationship there. So here we know that S1 is going to be bigger than S2, or S sub 1 is bigger than, side 1 is bigger than side 2. So if I know that is the case, then I could write something like S2, S1, A. And if I knew the order of those things, then I could for sure draw exactly the same triangle with just that information. I could say, I've got an angle, I've got side 1, and I've got side 2. So I could just use those 3 pieces of information and end up with congruent triangles. Which is pretty cool, which is pretty unique. So that, when we talk about the capital S, lowercase s, a triangle congruence theorem, we need to come up with some fast way of saying that. It's called big S, little s, a triangle congruence theorem. Most of the time you'll see it in written form. You won't need to say it, so you'll write about it. But know that the order of your sides matters a lot. So you had the big one before the small one in order. So this would be small, then big, then angle. Then that would work. So I could write this. I could write the small one, then the big one. And we use this convenient convention of having a lowercase letter represent the smaller side, and the uppercase letter represent the larger side of 2 sides in a given triangle. And the next theorem I want to talk about is called the hypotenuse leg triangle congruence theorem. The hypotenuse leg triangle congruence theorem. So where does a hypotenuse occur? Well, you should be able to answer that fairly quickly. Hypotenuses only occur in right triangles. They occur opposite of a right angle. So the hypotenuse is the largest side in a right triangle, but you can always remember that's going to occur opposite. It's going to be the opposite side, opposite of a right angle. So this is our hypotenuse. So let me give you a scenario. Let's say I have a hypotenuse of length 10 inches. Let's say inches. I could say light years, I could say meters, I could say miles, I could say furlongs, hands, I could say, there's all sorts of length measurements, but I'm going to use inches here. Hypotenuse of length 10 inches. And then I have a leg of length 6 inches. So you should know that the fact that this is a right triangle I have a hypotenuse of length 10 inches, a leg of length 6 inches. Well, there's only one length that could occur in the for the other leg. I've got 10 inches here, I've got 6 inches here. There's only one length that occurs on this other that can occur on this other leg. I can know this through the hypotenuse leg triangle congruence theorem, or I can know this through a simple use of the Pythagorean theorem. So when I use the Pythagorean theorem, well, if I know two sides, remember Pythagorean theorem is a squared plus b squared is equal to c squared. If I know two sides, then for sure I can know the third. So let's just do this real fast. You might immediately recognize that this is just a version of the 3, 4, 5 right triangle. But, so you might say, oh, obviously this side's going to be 8. But let's just go through the Pythagorean theorem to prove it. So c squared, c is 10. 10 squared is equal to 6 squared plus b squared. 36 plus b squared is equal to 100. B squared is equal to 100 minus 36 is 64. Square root of both sides. B is equal to 8. Awesome. So the hypotenuse leg triangle congruence theorem could really be viewed as a direct result of the Pythagorean theorem. Direct result of Pythagorean theorem. All right, y'all have a great weekend. Know that when you get back to class, hopefully you have class Monday, you will have a little quiz which talks about the big S, little s, A, triangle congruence theorem. It talks about the ambiguous case, and it talks about the hypotenuse leg triangle congruence theorem. It's going to be 3 questions. They're going to be real simple. If you've watched this video, you should be able to answer them. Bye.